Glasstech Asia. Hi, a very good afternoon, everyone, and welcome back to the 8th installation of Glasstech Asia and PERAFI webinar on applications in facades and buildings relating to safety and technology. Talking about safety and technology, this has been long-term goals for the global facades and building industry. As we approach Glasstech Asia 2022, which will be held next week from Wednesday to Friday, 26 to 28 of October at Marina Bay Sands Convention Hall, Singapore. What a better time to consider the landscape and the challenges our architects may encounter in applying safety and technology into our built environment. For anyone interested to know more, we invite you to join us at Glasstech Asia next week, where you will be exposed to more valuable and thought-provoking industry subjects. I am Gwen from Dow Asia Pacific, and I am delighted to be your moderator and host for today's webinar. Before we start, let me thank Glasstech Asia and PERAFI for putting this platform together and bringing a network of glass and facade professionals, including myself, to learn, share ideas, and also explore new possibilities. So Glasstech Asia, for those who are not familiar, is actually an annual rotating exhibition that focuses on all things glass. It is a showcase for windows, doors, facade innovations, and is held in conjunction with Fenestration Asia. And this year is really special because Glasstech Asia will coincide with the United Nations designated International Year of Glass 2022. So we hope you will lend your support and promote the event with your network and encourage all your network to join us and learn more about the glass industry. I would also want to acknowledge PERAFI, which is the Indonesia Facade Association, an independent organization dedicated to improving the quality of the building facade industry and developing long-term, meaningful business relationship. So a call out to all our Indonesia fellow colleagues. Please do check out and join as a member of PERAFI if you have not already done so. So before we begin, please be informed that we will disable your video and microphones. Throughout this session, if anyone has a question for our speaker, you can post it directly to the Q&A chat box. We will cover them during our Q&A sessions. For any unanswered questions, we will link you up to the speakers after the webinar. So our program today will be about 2 hours, and we have 5 veteran speakers with diverse and rich expertise, bringing us provoking contents on applications relating to safety and technology in facades and buildings. And today's webinar is actually made possible with the kind sponsorship of AGC Group and Asahimas. AGC Group is a world-leading supplier of glass, chemicals, ceramics, and other high-tech materials and components. With the slogan, "Your dreams, our challenge," AGC strives to solve everyday challenges through cutting-edge technologies, looking beyond the obvious today and bring bolder ideas to make people's life better across the globe. So without further ado, let's dive into our program today. I would like to welcome our very first speaker, Philip Kwan, Director of Facade Global Master Private Limited and SG Glass Innovation Master Private Limited. He is no stranger to our industry. Mr. Philip Kwan is an expert and veteran in the glass and facade industry. He also serves as a lecturer at the Department of Architecture in NUS and BCA Singapore. Philip is also a co-inventor of LES, which stands for Light Emitting Surface. And we are very privileged to have him today to do a tech talk on moonlight architecture. So before we have Philip takes the stage, we will want to share a video that the crew has prepared for you. So IT over to you to play the video.
LES technology is the breakthrough lighting on glass. With no glare or heat produced, LES provides a uniform, ambient night lighting. Feel serene and relaxed with LES Moonshine. Just right at the doorstep of your house.
I'm unable to share screen. Can Nani?
Hi, Philip. Can you try again?
Okay. All right. Okay. Do you see my screen?
Yes, Philip, we do see your screen.
All right. Thank you very much. Thank you everyone. And today I'll be speaking about moonlight architecture. Now, let me start with a problem, okay? And this problem relates to the universal problem of light pollution, of which Singapore has been named as the world's most polluted light polluted city in the world, right? And that is because Singapore never sleeps, right? And light pollution is very harmful to human, very harmful to our mental wellness, and very harmful to ecological balance, especially to nocturnal animal, because when we have excessive light, we have excessive pollution, and that will be a big problem. Well, most of us may not know is and it's generally accepted that light pollution is caused by excessive use of artificial lights, and this artificial light is actually made to be a replica of the sunlight. So every artificial light, whether it is a traditional light bulb, whether it is a tungsten light, whether it is our fluorescent tube, or even the LEDs, they are made to replicate the sun. No doubt they are good to help us see things, or to help us find our ways around, but they are essentially also bringing the issue of glare and heat to our environment, right? And glare and heat is the main cause of light pollution and the main drawback on excessive use of lighting technology, right? So what can we do about using artificial lighting without having the heat and glare? Now, we talk about it as a technology, and we say, since we are using mostly artificial light that is produced according to the characteristic of the sun, why not we have something that is produced according to the characteristic of the moon? And this is the reason we founded LES, a light emitting surface. The surface is akin to the surface of the moon. We reflected light, and we call our lighting technology the moon represent our light. Yeah? The heart of the technology is that moonlight doesn't produce heat, doesn't produce glare, because you can see the moonlight from the further distance, and therefore it doesn't cause any light pollution. Now, I'm saying this not because we think that the moonlight or LES will eventually replace LEDs, but we think that a sunlight artificial lighting and a moonlight artificial lighting could harmonize to build a better environment for ourselves, right? Now, LES is an award-winning technology. It was named as the world's first printed lighting technology. And since then, we have been internationally patented in China, in Japan, in Taiwan, in Singapore, of course, in Europe. And also the trademark is also been registered trademark. On the day we launched our LES, we had immediate recognition from Philip Stark, the world's most renowned interior decorator, and with his blessing, we were able to put out LES as a pilot project in South Beach. Right. Many people ask me what is the characteristic difference in between the LED and LES. Okay, the LED obviously is the sunlight version of the artificial lighting. LES is the moonlight version of the artificial lighting. But these are just claims, other than the fact that we have actually used LED lighted canopy over a salvage, and this was done by me way back in 2016. And as you can see, in terms of the what you call, in terms of the energy use is 330 watts per meter square. Cost is way above $2,000 a meter square. In comparison, we have LES canopy. LES canopy in terms of energy use is only a fraction of the LED canopy. In terms of cost, because we have integrated multifunctional feature into the light, the cost is reduced from $2,000 to slightly less than $800 per meter square. In terms of functionality, LES, the LED is of course function well as a canopy, but at the same time, it's also what you call shining extensive light on the people below, and also causing quite a bit of light pollution in the area that is otherwise supposed to be cool and calm. Throwback to today, the same LES could be designed with high aesthetic. In fact, LES can be produced in all kinds of patterns, any patterns that is of your preference, so that it can achieve what you call the aesthetic that is typically associated with high architectural value, right? In terms of fire safety, more and more LEDs are being used, but more and more LEDs are plastic, as and plastic is typically not very well accepted by our fire authority. Whereas LES is fully encapsulated between two pieces of glass, and that immediately will place a lot of confidence in terms of fire safety, right? Another example of LES is typically used on facade as facade lighting. And if you can look at this what you call illustration of a project we did in China, LES is completely what you call visible in high clarity, even from the longest distance. Compare this with the LED lighting that are somewhere at the bottom. They are somewhat they're not as clear as they should be, right? So LES is fundamentally a canopy lighting, a facade lighting, and more than that, we also use it as a signage. And this is a very telling picture, because these two signages, one is made of LED, the other is made of LES, and these two signages are in the same office within a short distance from each other. But as you can see, the effect of a LED, you get uneven lighting across the surface. You get dark spot. You basically don't have the luxury of lighting out the entire piece of communication letterings and all that. Whereas LES, as you can see, is clearly visible, even though the lighting condition there is even harsher than the one that is being placed with the LEDs, right? So LES can be used as a partition screen for decorative purposes, but a lot of the LES is now being used both in China, in Singapore, as well as in Thailand, as a security screen. Because as we dim our light, we need what we call our handrails and balustrade, for example, to be littered out so that they can serve as a wayfinding and security, what we call security arrangement. And LES can come in different colors. We can come in blue, green, white, and even the golden color, right? Now this is an experiment that we did for Singapore HDB block signages. A typical block signages will have a light pollution that is glaringly going into 150 watts per box, right? If the same box would have been done, and this is actual measurement, we will end up with only about less than 10 watts. So between 154 watts and 10 watts is a lot of difference. But if we were to extrapolate to the entire HDB blocks with 20,000 units of LES, we can save as much as 12 million kilowatt hours per annum of energy just by changing from LEDs to LES, right? And the energy saved is the equivalent of 25,000 HDB units, right? So this is a huge, is a huge number that has taken the attention of not just HDB, but it was in fact debated in the parliament under the cost of supply debate, right? So LES is not just used for external. Well, what we just described is external canopy, balustrade, but it has also found its way into the interior decoration, especially with regards to mirrors. Okay, we can light up mirrors with LES with all kinds of design, and it will add a lot of class to the building, right? So we have a showroom in Delphi. All of you are welcome to visit our showroom anytime you want. And if you like, you can contact me under those contact information provided, right? So thank you very much.
Thank you, Philip.
Right.
Yeah, thank you, Philip, for the very insightful sharing. So now we'll open up for Q&A. So let's check whether there's any questions for Philip. Just one moment. Yeah. So let's wait a while to see. I think the questions are coming in. But I really like what you shared, Philip. Moon represents our light. No heat, no glare, and no pollution.
Yeah.
Yes. So, Philip, there's a question that asks, why is LES considered green and sustainable? Could you give us some insights on this?
Okay, I say in my, today, green technology is all about energy saving or energy producing, as in solar, right? So LES happen to fall under the category of energy saving because everyone today think of LED as the most energy saving light in the market today. And government are promoting LED as the energy saving light. But then what they fail to realize is we have a LES, which is only consuming a fraction of the energy, energy used by LED. And in the showcase example that I cited, if let's say the whole of Singapore were to change the block signages from LED to LES, there is a huge saving in terms of as much as 12 million kilowatt hours of energy per annum. So in that sense, LES is not just about aesthetic, not just about functionality, it's also about energy saving in terms of how it can contribute to our national goal of sustainability.
Thank you, Philip. There's another interesting question that came up. Is asking that since this lighting technology is installed inside the glass, does it mean that it has to be laminated or double glazed?
It is laminated, but it is laminated with a special PVB that is considered moisture resistant. So even if you put LES out in the open, standing out as unprotected balustrade, it will not be contaminated or delaminated because of our special, what we call our special arrangement.
Okay, all right, interesting. So Philip, how about the lifespan of LES?
Okay, LES is a long life product. It has been tested to continuously for up to 30,000 hours with no catastrophic failure, right?
So 30,000 hours.
Yeah.
So what will happen after 30,000 hours? It has to be replaced.
I think LES is the only light that is classified under the non-catastrophic category, because most light after the certain lifespan, they will simply die. What do you call? They'll reach the end of their life. Right? Whereas LES, although they may after 30,000 hours, they will still remain at least a certain percentage of the light, and this light can be what you call tuned back to its normal capacity and continue to be used for a much longer period. Right? So it is completely non-catastrophic. Even LEDs, although even LEDs are known to be completely run down to zero under certain circumstances.
Okay, great, wonderful. All right, thank you so much, Philip, for sharing with us this new technology. I encourage all our participants here, if you have further questions, please do reach out to Philip. As you can see, his contact is actually on the screen right now. Yeah, so please feel free to reach out to him and hesitate to visit his showroom. So next in the highlight, we will examine the ETFE roof for a safer future. I'm pleased to introduce Richard from Syntech. Richard actually co-founded Syntech in 2013 and worked closely with AGC to market building materials and constructions projects in the Philippines, and aims to bring innovation and safe products to the market through his network of customers. Syntech has successfully marketed ETFE in the Philippines, earning its first project after a short span of 2 years. Syntech now works with local installers and established international ETFE fabricators to bring the best value and engineered products to its clients in the region. So without further delays, I would like to pass the time to Richard, but before that, let's all view this video. So over to IT to play the video.
AGC constantly strives to provide customers with high-value solutions and functional products. We offer a wide range of materials such as glass, chemicals, electronics, and ceramics, and have a strong presence in many countries around the world. AGC's aim is to provide valued solutions in high-quality materials to people around the world. Our fluoropolymer resins for coatings is used in many places around the world. Our fluorine film is used in Allianz Arena in Munich, Germany. It's also used in many stadiums and architectural constructions worldwide. AGC's display glass is used in smartphones around the world. Our glass plays an essential role in presenting clear images. At any point in time, AGC is playing a part in supporting society somewhere in the world with the provision of unique materials and solutions.
Richard, over to you.
Thank you very much for the introduction, Gwen. Hello, Eric. Good afternoon, everyone. Give me 5 seconds to share the screen. Can everyone see my screen?
Not yet. Yes, now we can.
there seems to be a lag, but please raise your hand if for some reason the feed gets cut off so that the IT guys can work on it accordingly. So as what Gwen has introduced, my name is Richard Ng. I'm a co-founder of Syntech, and the topic for today's speech would be Roof for a Safer Future using ETFE film. So just a quick intro. As I alluded to earlier, the company was first started in the Philippines at the behest of AGC to market ETFE, essentially. At the time, ETFE was not a very well-used product back in 2013. So we were tasked to market the product in Philippines to try to see if the reach of AGC can extend beyond the traditional markets of Singapore and Hong Kong as far as ETF is concerned. So in this slide, the BCD essentially refers to the value chain of the entire ETFE. So there is a collaboration between AGC. They are the biggest manufacturer of ETFE in the world. So there is collaboration with Syntech, and I'm also an ad hoc consultant for AGC, hence my participation in today's event. C, the raw material that AGC sells will be purchased by fabricators who will process the ETFE into the panels, very much like glass fabricators that will cut, they will prepare, they will process into the form that has been designed. And then finally, once the product has been produced and delivered, we will work with our local partners in the various countries to make sure that they are properly installed in conjunction with the fabricators that we work with. So we are present in Philippines, of course. HEAD is our local partner, and we have partners in Indonesia, Thailand, and Vietnam as well. So what is ETFE? The fortunate thing is that since 2013, there has been increasingly extensive use of ETFE around the world, particularly in stadiums. You might have seen the use of those products in stadiums, particularly in the US. All the new stadiums in the world these days actually use ETFE in some form. I will share that in the subsequent slides. But by and large, I'll just run through very briefly the characteristics of ETFE, how they are being applied in buildings, the type of ETFE installation, and the comparison with other materials such as glass, PVC, PTFE, and what have you. So this is just something that I lifted from Wikipedia in case anyone is interested in the scientific description of ETFE. It's just ethylene tetrafluoroethylene. And like what the earlier video has demonstrated, it is a fluorine-based plastic. And it's just very well developed and researched by AGC. I will share a video. This is lifted from the YouTube. It is a fantastic source material for ETFE. So this is one of the many videos that I found that perfectly describes and depicts what ETFE can do and the advantages of which. So the video that you saw just moments ago is a stadium in New Zealand, Dunedin. The entire facade plus the roof of the stadium is all ETFE. You probably can't make out or touched it, but it is something. There are multiple videos showing that stadium, which is a unique material or product in itself used for facade and roofing. Now, why is that the case? On the left side of my slide, you'll notice there's a list of characteristics for the ETFE. It has exceptional transparency, high light transmission, and probably the most critical characteristic of ETFE is very, very lightweight. It is akin to plastic, but it is not plastic. It is, like I said, a fluorine-based product. So because it is lightweight, it allows for very long span in the panels, unlike glass, where it's probably at the very best 1 meter by 1 meter or 1.5 for roofs. It can take on any shape. So think of it as fabric that can be tailor-made into whatever shape the architect wants or the designer wants. And also because it's lightweight, very minimal support structure. So you're talking about extremely high savings in steel tonnages. Fire safety is non-combustible. Again, YouTube is a fantastic source of material for fire safety. It doesn't propagate fire. So once the fire is removed from the ETFE, it stops burning, and there are no drips. Chemically, it is inert to, in fact, almost all active solutions. Self-cleaning. Again, unlike glass, it's like you need to have maintenance, but as long as you have rain, ETFE cleans itself, and the product is recyclable. That's 7. You can also introduce solar shading on ETFE. So if you have specific U or G value that you want to achieve, and that can be customized with the use of prints. So this is sorry about that. And this is a unique and very important research that AGC has undertaken, and he has moved on since 2013 to ensure that the reflectance of solar or UV improves with every new development that they have done. So the one on the left is current film available in the market today. The one on the right is K ink. The one on the left is standard silver. So AGC has developed the K ink that improves the reflectance of solar. So if you look at the numbers in yellow, it will tell you the story of how much of a reflectance it has improved. And they are also now moved into an even better ink, which is the W ink. And this one has the best reflectance of solar for ETFE. And also to add, AGC is the only manufacturer of ETFE and prints that will guarantee its product for a minimum of 10 years. No other manufacturers can do that. So that's how far and how well they have done their R&D. Number 9, another characteristic is the superior weatherability. The product was first used, I think, about 35 years ago. I apologize for the number here, 27 years. It should be amended to 35 years already. So the optical properties and mechanical properties, by and large, stays about the same. So it's a highly durable product. And also the R&D involved undertaken by AGC is to improve on its haze and high clarity. So that is something that's under R&D right now. So in probably end of the year, as I was told, that this product will contain low haze and high clarity to a very large extent when they push out the product. And finally, one of the key characteristics is the strength of the ETFE. It can take on the weight of a car in its form. So the critical conditions critical considerations in ETFE application. Importantly, other than making sure that the loads are properly taken into account, you also want to think about the seismic loads, the surrounding buildings, and others. Glass has been a dominant product for roofing and facade for, I think, since it was invented. But with it comes various disadvantages. For example, in volcanic regions or where there's high earthquake activities, typically when building collapses, there'll be a lot of debris. So in the use of ATFE, you're talking about not minimal, but definitely relatively less steel structures compared to using glass. And you don't have glass shatters, unlike ETFE, which is essentially plastic in a lot of ways. And also for surrounding buildings, we're talking about if you're using glass as a roof for commercial complexes, anything that falls from the sky, be it steel pipes, be it heavy objects, you immediately break the glass roof in the commercial complex below. So for plastic, you just essentially puncture through the ETFE without causing any shatters. And then finally, the fire safety, chemical spills, and maintenance are something that you also want to consider using ETFE instead of traditional glass. So we'll move on to applications of the ETFE. And again, these are all pictures I lifted from the YouTube. So it is very universally accessible by everyone. These two projects, the one on the left is the entertainment sector in Kazakhstan. There is an entire YouTube video describing how the entire facade, which is ETFE, was built from scratch. So it's actually a discovery program on this project. And on the one on the right is the Beijing Aquatic Center, which is also in the discovery program available in the YouTube. So you notice it's like the ETFE can take on any form. It doesn't really have very rigid structure, which is what the architects and designers love these days. More stadiums, the Bird's Nest, also in China, and the National Stadium. The retractable roof is made out of ETFE, and at the same time, you will also notice that ETFE acts as a projection screen as well. So this is a project that I did in the Philippines, or installed in the Philippines. So this is the Mactan Airport, particularly for walkways from the drop-off point to the terminal in Cebu, Mactan. Skylight, use of ETFE in skylights. This is in the Philippines Mall. The one on the right is in Hong Kong for artistic expressions. And the use of LED with ETFE, and it gives you a completely different look at night with the use of lights. And in fact, you can probably incorporate this. AGC can probably work with Philip, in making sure that LES can also be incorporated into this product.
Yes. Thank you.
So I'll move on to the two types of ETFE installation that is available in the market. One is the single layer tension system. This is a project in Jordan. You notice on the roof, those are entirely single layer ETFE. Facade using single layer as well on the left, and also for a school as a canopy on the right. So it's a combination of transparent ETFE and opaque PTFE. And the second type of ETFE installation are your cushion. So it's essentially two pieces of ETFE inflated with air in between. So the entire system will consist of an air pump or air inflation unit. You can see the bottom left, a typical picture of an air inflation unit, pumping air through an air tube into the space between the two layers of ETFE, creating an air pressure within the two layers. And all these are supported by steel and aluminum. Just a close-up of an air inflation unit. The one on the left, you will have a primary blower and a backup blower, and it will have to be installed within 100 meters of the ETFE project itself. So you notice on the picture on the right, the air is pumped through a stainless steel pipe, and then after transported across all the different ETFE panels and relay into each individual panel via the air tube. So I was also mentioning that they are all supported by steel structures and aluminum extrusion. So these are typical cross-section and side profiles of aluminum extrusion. Well, we can probably talk about this in detail, but we don't have the time for this. So I'll just skim through this presentation, this particular slide. So comparisons with other materials. In a snapshot, I'm talking about comparisons with Lemiglass, insulated double glaze, low E, PVC polycarbonate, PTFE. So you will notice that the key or the fundamental differences between this product and ETFE, other than PTFE, is essentially the weight itself, and also the U value and the G value, which you can customize according to your set values or what you wish. So this is just a snapshot of the very many characteristics of the different materials that are in use today for facade and canopies. So increasingly, you will notice that ETFE has been considered as the go-to product, particularly for roofing, simply because of the nature of its of the product in itself, and how flexible it can be in offering architects and designers their flexibility and also the non-restriction as far as imaginations can go. So I think that is fundamentally or rather essentially the end of my presentation. I hope I kept within the time.
Yes, you did, Richard. Thank you for the sharing. I love especially all the project references. They all look so fantastic and aesthetically very nice. So Richard, we do have a question from our participants. This participants ask, ETFE, can your company also assist in the design development?
Yeah, in fact, we encourage our customers to get us involved from the very beginning, simply because the calculation of loads, the engineering, and what have you, it's not something that is familiar to everyone. Everyone is familiar with glass. The loads involved in accordance to the building codes for each country. But ETFE is a completely different animal. And you will need to understand that we need to optimize the steel to make sure that the steel structures or the use of steel tonnages are minimized. Otherwise, it's a complete waste of resources if you just want to use ETFE but maintain the same kind of steel structure that is supposed to be set aside for glass in the very first place. So I always encourage customers to work with us from the very beginning so that we can work together, either with our steel designer or with their own steel designer, in coming out with an optimized structure.
Okay, thank you, Richard. That is, yeah, that's a very nice presentation. And do we have any more questions on the floor? Let me just check again. Yeah, I think that's the only questions that we have. But we do encourage participants as well to keep putting more questions on the chat box, because we do have another session of Q&A towards the end. For now, let's move on to the next session. Next up, let's hear from Lina Lu from RSP Singapore and Vance from Arab Singapore. So a quick introduction of Lina. Lina actually has more than 30 years of architectural project experience, and her portfolio range from residential, education, infrastructure, sports and recreation, hospitality, offices, and retail projects. And for Vance, he's an associate with Arab Singapore Private Limited, and he has a deep understanding of design, production, and site challenges from his very early days of industry experience. So now, let me pass the time to both Lina and Vance to discuss the topic of Capital Spring challenges in high-rise facade design. All right, Lina and Vance, hand over to you. The floor is
Okay.
yours.
Okay,
Okay,
shall I
thanks,
share
Gwen.
the screen? Thank you. Okay, can you see the screen?
Yes.
Okay, let me start. Thank you for having us for this webinar, and thank you, PERAFI, through our RSP Indonesian office for inviting us to this webinar. So I'll be here to explain the capital spring, the design aspect, and Vance from Arab will be explaining the facade details. He is the facade engineer for this project. So capital spring, it is designed by BIC in association with Carlo Ratti. BIC is a company in Copenhagen and New York. So as you can see, this is a newly completed office tower in the Singapore CBD area. It is located within easy walking distance of Raffles Place MRT and Telok Ayer MRT, and then it is near the Singapore River. The site is very close to the heart of the Raffles Place MRT area. And in the existing location, there used to be a 10-story office building, which is 10-story car park building, which is called the Golden Shoe Car Park building. So at that time, this building was used to park your cars if you're visiting the Raffles Place area. And what we have done is actually transform a car park building into a building for wellness, for functional use. As you can see, there's evolution of the site on the left from the car park building to a modern day office building, which is biophilic in nature. And the design inspiration from BIC, he takes inspiration from nature in the city and he creates a visual interest through the multiplicity of layers. And as you can see, within an entire tower block, they have interspersed nature within at ground level, at mid-level, and at top level, even at the roof level. So this is an example of the urban context. So we have a view towards the Singapore River, towards Cecil Street, Telok Ayer Street, and Pickering Street. And as you can see at the bottom, we have Raffles Place. At one corner of the site, the ground floor area is given to a public space, which we call the city room. And this facilitates the commuter flow and the pedestrian flow in the area. Now, this city room is a new ground activation place and it connects with the new park area. We also have new linkways which will connect you and shelter you all the way to Raffles Place through the next door building to Raffles Place MRT. So there's an increasing access and engagement with nature, and we have actually reintroduced nature within this area. A portion of the market street is closed off and it becomes a public park and it integrates with the city room at ground level. So at the city room, this is a public communal space where there are activities sometimes happening, sometimes Christmas celebrations, and there is a public artwork kindly sponsored by the developer, which hangs over this city room area. Okay, now regarding the facade element, as you can see, this is a 51-story office building. At the rooftop, we have restaurant and a sky garden. We have an office component. In between the office and the service apartment, we have a green oasis. We have swimming pool and landscape area, car parks, hawker center, and restaurants. So what BIC has done is for the design, it actually integrates all the programs within one design and into a uniform whole so that it looks like a unified biophilic tower without any breaking of it into different forms and different formats. So we go on to the facade. So we have a vertical element, which is like the fin. So this vertical element runs throughout the entire building and it opens up into pockets where you can actually look into the green terraces within or the public spaces. So this is an example of the peeling effect where the building actually peels back and reveals what is hidden within. And this is what gives the Capital Spring facade its distinctive appearance. Now, one of the challenges of the facade was the production of the very long curved fins. So the length is restricted to up to 7 meters due to the restriction in size for the PVDF coating. And also due to the limitation of the bending machine, the radius of a curve cannot be less than 4 meters. So all this geometry was worked through together with BIG, together with the curtain wall specialists, and also with Arab Facade. And it was optimized by use of various programs like Rhino and Grasshopper. So this is just an example of the facade at the podium level, where the facade, there's embossed panels, perforated panels with different type of percentages. And the different type of percentages are used where they are required at different areas, especially at the M&E rooms where the perforation is much more. And also for the use of glass, it was also actually studied in conjunction with the facade consultant, and the types of glass used was in relation to the usage, like the office area, the podium area, and a kind of gray color glass was chosen, but the thickness and the type of glass was taken into consideration. What are the spaces behind these areas? For the podium level, the facade peels open to reveal pockets of greenery, which serves as an interesting facade element, and the trees will relate to the human scale. So you can see that even from the hawker center, those of you who are familiar with Singapore, you know that this previous site, there's a kind of iconic golden shoe hawker center, which supplies food at economic prices to the CBD workers in this area. So the hawker center has been relocated back to the second and third story of this building. And as you have a meal, you can enjoy the pockets of greenery, which is through the openings in the facade. So for the hawker center areas, the facade actually consists of louvers, which are tilted at different angles, and this will allow for light and ventilation into the building. For the next zone, which is called the Green Oasis, these are elevated gardens which are open to the public, and it provides a mid-zone visual relief to the neighboring buildings. So these communal gardens also acts as a social space for both the tenants and the public, so you're free to take a stroll in this area. And the designer has looked into the programmatic design aspects regarding the cutouts, the placement of the utility services within the core, and how the route is routed through a spiral around the tower's core. So as you can see from here, there are various levels in this green oasis. There's a rainforest aspect in this green oasis, and there are various activities programmed within these areas where you can sit down, you can have a chit-chat session. There are some areas where you can have a display, you can have a yoga session, and you can interact with each other. So this is another view of the green oasis. As you can see, it's very largely vegetated with tropical plants and also with exercise equipment. So you can go for a quick stroll after your work and exercise there if you want to. The fins actually and the pockets actually also frames the view outwards. So you can actually see the previous Parliament building. You can see Raffles City, the Padang from this area, Singapore River. And it forms a beautiful backdrop. We also have the service residences, which is at mid-zone of the building. And the service residences offer private living and co-living spaces. And the next block, we have office floors, which actually is from level 21 to 49. So this is a typical office lift lobby with column-free floor plates and very high floor efficiency. So for these office areas, as you can see from the tower facade, we have actually full height glass windows. It provides the offices with amber light, natural light. The Sky Garden, which is right at the rooftop of the building, it is also open to the public during certain time. We have the client has done together with the restaurant area, the edible gardens. So the edible gardens and the Sky Terrace, this area is the highest point, And this is Singapore's most elevated observatory deck at 280 meters. It is open to the public. You can go up to enjoy 360-degree panoramic scenic views. You can take photos of the Singapore skyline from here. There is also the urban farming aspect where they have a farm to table. So there's a liaison relationship with the restaurant where there's some of the vegetables are grown up here and they are served in the restaurants. Okay, this is an example of roof garden. Okay, Vance, your turn.
Yep. Okay, thank you, Nina. Yeah. So first of all, I want to thank PERAFI and RSP for inviting me to co-present about the facade design and the maintenance for Capital Spring. Right. So I'll just continue off from where Nina had finished. So in here you can see because for a 280 meters tall building, and we have also fins in front of the curtain wall, how do we maintain the facade? So we actually, in the early stages, with RSP, we dedicate a space on top of the roof core to have the BMU park there and actually deploy out to maintain the facade with a glass replacement unit capability on top of the chip. So this is for future glass maintenance, glass replacement should a glass break spontaneously, or if there's issues with the glass, and also for the purpose of inspection. Next. Okay, so as you can see, the BMU or the building maintenance unit is located at rooftop at the core to clean the facade. Okay, so it can be retracted when not in use, and it can be concealed from view when for people standing on street level within the service core. Why is this so? Because this is actually an authority and a client requirement that the BMU should be always concealed when it's not in operation. So next slide. So this slide, this you can see a picture of the BMU actually deploying over the parapet wall of the core wall to maintain the facade. Okay, next. Yeah, the next topic I want to discuss is about computation design, understanding facade design intent. So the original concept from BIG, we have louvers on the podium with fins. So actually these louvers are meant not just for aesthetic, but they also have ventilation and thermal comfort and daylight purposes. So during the design, we have a lot of pockets, as you can see, with complex geometry and the tilting louvers. The top right corner shows the different types of tilting of the louvers, from 80 degrees all the way to the flat ones. The flat one is a green ones. So how do we explain to the contractors or the tenderers when they are bidding for the job, the design intent of louvers, if we are, it's not productive and it's not possible to show the different location, different type of rotation on 2D drawings. So if I can see from the next slide. Yeah. Right. So this is a typical drawing of the fin of the louvers incorporated next to the fin. So as I said, it is not possible to show different rotating angles, and they are actually also different angles at different locations of the podium. So what do we do then? So we use Rhino and Grasshopper software to identify where all these different tilting louvers are, and then show them on an elevation markup, like what you see just now. So then it allows the tenderers and contractors to understand them better, and also to allow them to price it more accurately, as well as when they are on board, they can develop the shop drawing as per the intent. Next. So the beauty of the parametric design or the 3D is during the design development, we can carry out design optimization for the food center to address ventilation performance, daylight, and rain penetration using the Grasshopper plugins. So the diagram on the top left, these are screenshots of how we actually control the model to show the different rotation of the louvers that allow, as you can see on the top right, is the daylight coming in through the podium facade. Okay, so it reduces our man-hour operation as well as improve efficiency during the CFD studies and the thermal comfort analysis, and also improve the design in terms of occupant comfort and well-being of the occupant in the space. Right, so the bottom right-hand corner, yeah, it shows the different conditions when the daylight come in and when the user stands, say, next to the facade, whether is it too hot or too cool, and whether there's adequate daylight. The tool also allowed various permutation study of the daylight assessment to determine the location and species of vegetation in the green oasis to improve space quality. So the image on the bottom left, it shows a different location of trees in relation to the pockets on the green spring where it opens up, so that we can study whether there's adequate daylight coming in to have the to let the vegetation enjoy the daylight. Yeah. So I think that's the end of our presentation. The next one will be showing the video of the whole project. So please enjoy.
Thank you, Vance and Lena, for this very interesting sharing of this project. Really gorgeous building. I had actually an opportunity to attend a workshop in that building, and the developer was kind enough to tour us around. And I really like the garden, you know, the open space that allow people to do yoga. And also I remember they said the food, the place where they grow their own fruits, that was really amazing. Yeah. So Lena and Vance, we do have some questions. So I'll go ahead and kick off the first one. Beside the BMU system and the monorail system, what other systems are used to clean the facade on other areas of the buildings?
Okay, so maybe I'll answer that question. So okay, we have a main BMU that maintains the tower facade. There's a monorail system that actually maintains the green oasis facade also, the fins and the inner cladding. On the ground floor, there's also a boom lift that cleans actually the level 1 shop front. So the level 1 shop front is quite tall, about from 15 to 19 meters tall. So those need a boom lift that can reach this kind of height. Yeah.
Okay, thank you. So in the project construction, they have actually also considered very well how the maintenance is going to be carried out.
Yeah.
Okay.
Yes.
So let me check if there's other questions. So Vance and Lena, in your expertise, what do you think is the most challenging part when you work on this project?
Nina, maybe you like to answer this because you're actually more involved in the project than me during the construction stage.
I think it's COVID happened, right? So that was the most challenging.
Yeah.
Yeah. So there was the stop work, the restrictions, So I think everybody in the construction sector is well aware of all the difficulties we went through. Yeah. So every project had the same issues. Yeah.
That's true. The COVID has indeed put a lot of pressure on our industry. But despite that, it's good to see that the building has came off very nicely and very prestigious, I have to say.
Thank you. Thank you.
Yeah.
Thanks for a great team and for our client Capital Land and the contractor Dragach for really everybody working together. Yeah.
Yeah, it definitely take a lot of teamwork to make it happen. Okay, we do have a question on the Q&A. Let me read that out. It says that, as you can see, lead engineers are promoting eco-friendly product. That's probably for Philip. I'll probably post that question later towards the end. So maybe this question is more relevant for Vance and Lena. How to fastening or connect the curved fin in the green oasis?
Oh, okay. Let me answer this. Actually, the curved fins, internal of the curved fins, there are steel mullions. Those are the structure component to hold the fin together. Then it's cladded with aluminum. So the steel mullions are actually connected to the underside of the green oasis as well as the floor slab of the green oasis. So some of them span quite tall, 20 plus meters. There are also those that are like 15 to 16. So there are some, I think in one of the slides when Nina was explaining the green oasis, you can see a horizontal tying back to the round columns. Yeah, this is to prevent the excessive deflection of the fins when in service.
Okay, thank you. All right, thank you, Vance and Lena, for your sharing. It has been definitely very informative for our audience here. Thank you so much. So up next, I would like to introduce our final speaker, Derek Low, from Technoform Asia Pacific. So Derek earned a Bachelor in Mechanical Engineering from Nanyang Technological University of Singapore. He collaborates closely with Technoform's partners and customers to deliver optimized solutions for improving the thermal performance of their windows, doors, and facades. And today he will be discussing on how we may use facade technologies to ensure the safety and integrity of building facades. So similarly, he has prepared a video for us. So let's enjoy the video before he comes on stage.
Hi everyone. Thank you for attending. Just give me a moment while I share my screen. Hi, okay. Good afternoon, everybody. My name is Derek from Technoform, Asia Pacific, and today I'll be talking about designing safe and durable facades to ensure facade integrity of buildings. Today, we will be covering a few topics. We will first start off by revisiting the benefits of thermal bricks and warm spaces presented by my colleague Amos in the previous webinar. After which we will move on to talk about why safe use of thermally broken frame is important, as well as the durability of insulating glass. I will also talk about some of the standards which ensures durability and sustainability of ensemble frames as well as insulating glass. Lastly, I will also share some of the tests and services that Technoform provides. Without further ado, let us revisit the benefits of using thermal bricks as well as warm spaces. Aluminium is widely used for windows, doors, and facades for its good mechanical strength. However, aluminium is also a highly conductive material with a thermal conductivity of 160 watts per meter Kelvin, which is 160 times higher than glass. With exposure to the outdoor environment and solar irradiance, heat is absorbed and transmitted through conduction, convection, and radiation into the indoor air-conditioned environment. Due to thermal bridging, substantial heat is gained through the frame, causing the indoor frame to rise above 50 degrees Celsius at times. With heat transmitting through the frames as well as the edge of the glass, there will be additional unwanted heat transfer through frames and the edge of the glass. This will result in the inefficiency of air conditioning, as they will need more energy to remove the heat. In addition, building occupants will also experience thermal discomfort as the heat from the frames will be emitted from the indoor frames. So how do we reduce heat gain through the frames and the edge of the glass? We can consider inserting a low conductive material between the aluminium profile to have a thermal debridging. Technoform thermal brick is made out of glass fiber that reinforces PA66, which is an engineering plastic with thermal conductivity of 0.3 watts per meter Kelvin, which is approximately 533 times lower than aluminium. This effectively creates a thermal debridging and substantially reducing the heat gain through the fenestration frame, ensuring better indoor thermal comfort. With a thermal brick as small as 15 mm, we are able to improve thermal transmittance by 35%, and as SHGC has a direct correlation to the thermal transmittance, we see a similar quantum of 38% decrease in solar heat gain. Looking at the curtain wall frame performance, similarly by adopting a thermal brick width as short as 15 mm, you will be able to reduce the U value as much as 66% and the SHGC value by as much as 68%. We see a larger improvement for curtain wall system because generally uninsulated curtain wall frames have a much poorer performance due to the large depth. Therefore, from the improvements seen in both window as well as the curtain wall systems, a thermally broken system should be considered when trying to improve the frames. Here are some project references where Technoform solutions are being used. Apple showrooms as well as their campus commonly use jumbo size IGUs that are about 3 by 14 meters. In Apple Campus 2 in North America, they adopted Technoform's warm spaces to ensure the IGU are able to withstand the long loading as well as having great thermal performance. CITIC Tower in Beijing, the tallest building in Beijing with triple glazing curtain wall, they have decided to use Technoform's thermal brick in the system as well as warm spacer to assist them in obtaining LEED Gold certification. Another project in Beijing with a vision of reducing carbon emission, Beijing International Airport, designed by Zaha Hadid Architects, also incorporated high-performance glazing in the complex steel brick roof structure. Lastly, the current holder of the Guinness World Record for the largest glass window with a height of 70 meters, Taikang Tower in Beijing also adopted Technoform's thermal break and warmage spacer. Closer to home, Port of Singapore Authority has selected Technoform's solution from Super Low Energy Building SLEB Smart Hub, which is a database that is proven to assist in obtaining super low energy. The maintenance base is the first major building to be completed in the area with super low energy rating. As from the project references that I have shown, it is noted that the facades are getting taller and more complex. Glass are actually getting larger and heavier. Hence, there is actually a need to ensure that the facades profiles are sustainable and the glass are actually durable. Before I move into how to ensure the safe use of thermally broken frames and durable IGUs, let us first look at some of the reasons to why there is a need to ensure safe use of thermally broken frames as well as durable IGUs. As buildings get taller year on year, building facades are exposed to more environmental loads like wind as well as temperature change. When the frames are exposed to wind loads as well as temperature change, the frames as well as the windows will go through behavioral changes like bending as well as shearing. Traditional non-thermally broken frames are able to directly transfer the load from the external to the internal structure with ease, as the entire profile is made out of aluminium. However, with the introduction of thermal breaks, the aluminium profiles of the facades are now a hybrid of two materials, aluminium as well as engineered plastic. Therefore, there is a need to ensure that the assembled profile is still able to perform mechanically similarly to a non-thermally broken frame. Glass might not contribute significantly to the safety of the building facade, but durability of the insulating glass are equally important, as failure of insulating glass will mean that it will no longer serve the intended design use and lifespan. For areas where the day and night has large temperature differences, the cyclic change in temperature will result in the pumping effect of the insulating glass. With poor design consideration, this will result in gas leakage from the glass as well as moisture penetration into the glass. As such, to ensure safe use of thermally broken system and durability of glass, standards are put in place to ensure that industry manufacturers are able to follow and ensure that the end products are safe and durable. There are many recognized standards globally, and today I'll be touching on EN 14024, which documents the tests and requirements for mechanical performance of metal profiles with thermal barriers, as well as EN 1279, which documents the tests and requirements for insulating glass units. EN 14024 provides the industry stakeholders and professionals the requirements as well as the tests to ensure that the design as well as the components selected are of quality and will be able to perform as intended. Before we delve into the standard, it is good to note that manufacturing processes are also important in ensuring the safety and durability of the thermally broken frame. Traditional frames are traditional frames are a complete profile, and when loading occurs, the profile will bend rigidly. However, with the introduction of thermal break to the facade profiles, the profile will be required to be mechanically fastened. If the profile is loosely fastened, the profiles will bend at different rates. However, with mechanical fastening, it will bend at similar rate, but this will cause shear loading as well as the possibility of deformation. Hence, the assembly process plays a part in ensuring the assembled profile has shear strength strong enough to withstand the loading. So in EN 14024, they actually focuses on the tensile strength as well as the shear strength of the assembled profile, as the external facade are in constant exposure to wind and temperature loading. This will cause transverse as well as shear stress. In addition, facades are supposedly designed to last a long time. Hence, there is a need to ensure that the assembled profile must be able to withstand the test of time. This is why there is a need for testing and elongation of the assembled profile, as well as the transverse strength after aging, which is simulated with 1000 hours. Tensile strength has to meet the requirements at room temperature as assembled profiles needs to be well designed and manufactured. This is because the profiles will be part of the facade system and will be there for the design lifespan. Hence, there will be a need to also ensure that the assembled profile is able to perform equally well after the initial installation of the assembled profile. Hence, the profile are also placed through an aging process of 1,000 hours to simulate the building built for a long period of time. For climatic regions, there will be different seasons, and during summer, the temperature of the frame will be heated to high temperature, while during winter season, temperature might be reduced to possibly below 0 degrees. Therefore, the tests are to ensure that the assembled profiles are performing as per design mechanically at temperatures of 80 degrees as well as -20 degrees. As time passes with constant wind and temperature loading, it's also important to ensure that there is minimal elongation from the assembled profile, as elongation is undesirable. Hence, an deformation aging test method under loading is done at 80 degrees for 1,000 hours to ensure that there is less than 1 mm in elongation. In Technoform, we use materials that ensures that the elongation after aging is way below the requirement of 1 mm. As seen in the table on the slide, our thermal break profile as long as 24 mm has tested to have elongation less than 0.5 mm. Besides transverse stress acting on the facade system, longitudinal stress are also present due to the difference in temperature between the external and internal frame. As a thermally broken frame's advantage is to isolate the heat on one side of the frame. The heat trap which might increase the temperature of the frame to as high as 80 degrees at one side of the profile, causing expansion, which might lead to shearing. Hence, there is a need for a test to ensure that the assembled profile is able to withstand the shearing effect. In EN 14024, loading is placed on two ends of the aluminium profile at a slow feed rate, and the measurement is actually recorded. As we have looked at some of the test requirements for EN 14024, some of us might have the question of how are we able to obtain the desired requirements as stated in the standards. In the next few slides, we will look at what raw materials Technoform uses, as well as processes that ensures conformity to the standards. After testing on different materials and combinations, PA66GF25 has found to be the ideal choice for thermal breaks. This hybrid material is a combination of polyamide 66 with 25% glass fiber content acting as the strengthening agent. Technoform not only uses long virgin glass fiber to ensure good mechanical properties, we also tap on decades-long knowledge and technology to be able to weave the long chain of fibers into the polyamide, resulting in excellent strength that meets and go beyond the global standards like the deformation resistance shown in the previous slides. Besides having strong elongation resistance, PA66GF25 is the ideal choice in terms of thermal expansion. As the frames are exposed to high heat conduction, there will be linear expansion occurring, which will cause tension between the thermal break and the aluminium profile. Therefore, a material is needed to have similar linear thermal expansion. With aluminium's coefficient of 25 times 10 to the power of -6 per Kelvin, PA66GF25 is only 10% different, which means that the variation in length during the thermal expansion is similar between both material and it will lead to less stress on the profile. In comparison to aluminium and PVC, the thermal coefficient difference is 320%, which is so much more than PA66GF25, and it will lead to extra stress on the facade system. Hence, choosing the right composite material for thermal break manufacturing is crucial in ensuring a safe facade system. In the process of assembly, the proper execution of knurling, inserting, and rolling will ensure a good shear strength for an assembled thermally broken aluminium profile. Here are some of the examples of poor execution of knurling and rolling process. By selecting inferior quality of thermal break, cracks or even breakage might occur. In Technoform, we go beyond by supporting the customers by advising our customers the best practices in the assembly process so as they are able to meet the performance requirements. For facade system, which is the most exposed segment of the building, requires standards like EN 14024 to ensure that the facade is able to withstand the designed lifetime. Hence, with the right raw material, as well as the correct manufacturing process, this will allow an excellent assembled profile that will meet the requirements of EN 14024, which will in turn ensure the safety of the facade system. After discussing the EN 14024 that ensures safety of assembled aluminium profile, let us now look at another standard, which is EN 1279, which covers the requirements for insulating glass unit. As insulating glass takes up the majority of the window or facade system, we will need some form of evaluation that ensures that the parameters of the IGU, especially the safety portion, does not change significantly over time. So actually, EN 1279 are made up of 6 documents, each talking about different tests and requirements for each component of the insulating glass. But today's topic is focusing on durability of the insulating glass. So we will be talking more in detail about the product standard in 1279-5, which references the moisture penetration, gas leakage, as well as gas concentration test requirements in 1279-2, 3, and 4. So in EN 1279-2, they describe the test method of determination of moisture penetration index and specifies the requirements for insulating glass units. The average moisture penetration index has to be less than or equal to 20%. Moisture trapped in the IGU is something that we are unable to control, especially the manufacturing process is done in the open environment and in regions that are constantly humid. But with the excess moisture, this will lead to condensation happening within the glass. When the inner edge of the glass reaches dew point temperature, this will mean that the IGU has already failed, as it is unable to prevent condensation from happening. Hence, this test fluctuates temperature between high and low, creating the pumping effect caused by hot and cold climate temperature change. This will ensure that the IGU has a good sealant and to also check the moisture penetration. The picture on the bottom right shows what happens when condensation happens within the IGU, and the marks caused by the IGU, caused by condensation, will not be able to be removed without destroying the IGU itself. Checking the IGU to ensure that there is no gas leakage is also important, as gas-filled IGU increase the thermal insulation. And with gas leakage, the thermal insulation performance of the IGU will decrease. If I bring your attention to the purple dots on the slide, assuming the glass field is 100% at the beginning, the heat transfer coefficient of the insulating glass are the same at about 1.29 watts per meter square Kelvin. However, after 30 years, the IGU with gas leakage of 1% per annum will experience only about 8% increase in the heat transfer coefficient, like as you can see on the orange dots. But if we are looking at the black dots, the IGU with 3% gas leakage will result in 2 times the increase for the heat transfer, which is 16% increment in comparison to the original coefficient number. Therefore, we need to have a good IGU with good sealing, and that will ensure thermal performance of the IGU is built per design. So for gas leakage test, similarly to moisture penetration, the test also place the IGU in a fluctuating temperature to cause the pumping effect. And this will actually allow us to measure the amount of gas that leaks out after the test is completed. The 2 different types of tests in 1279 measures the moisture penetration as well as gas leakage, which will reduce the durability of the insulating glass. So how do we actually ensure that the moisture penetration as well as gas leakage is actually kept to the minimal? The spacer, together with the primary sealant, provides the gas seal as well as moisture barrier to the IGU. Warmage spacer not only provides excellent gas and moisture sealant, it also provides great thermal insulation properties at the edge of the glass as well. To ensure that the sealants and the barriers are good, EN 1279-4 Annex A portion talks about the requirements of having good glass to sealant adhesion. So in 1279 Annex A, the specimen are prepared with glass and sealant adhered together and is placed under a tensile machine till it is separated. This is to ensure that under loading, there will be no loss of adhesion between the glass as well as the sealant, which will cause moisture penetration and gas leakage. As Annex A in 1279 only talks about the adhesivity between the glass as well as the sealant, we should not forget that there is a possibility of moisture penetration as well as gas leakage if the sealant is not well adhered to the spacers. Hence, in Technoform, we take a step further to modify the adhesion test and test on the quality of adhesion between the spacer as well as the sealants. As mentioned in the earlier slides, we are moving towards the trend of having larger and clearer glass. This is why it's important to have durable as well as well-sealed insulating glass to not only prevent heat transfer through the edge of the glass, it is also to prevent moisture penetration that damages the inner coating, mold growth, gas leakage that will cause the insulating glass to not perform as per design. And this is why 1279 helps us in the testing and manufacturing of good IGUs. So today we covered standards that ensure the mechanical properties of assembled profiles with thermal barriers, which is EN 14024, as well as the standards that ensures the durability of the insulating glass, which is EN 1279. There are also other standards across the globe that also ensure safety and durability, like ASTM standard, as well as the AAMA standards, which I did not cover today. If you're unsure if your thermally broken window system will pass the EN 14024 standards, or unsure if your IGU are conforming to EN 1279, you can always approach us. So here in Technoform, beyond being a manufacturing company of thermal breaks as well as warming spacer, we also perform tests and services as well. With production plant distributed in 3 main areas, North America, Europe, as well as Asia, we are always near you in terms of supply. All our production plants and offices are ISO certified to ensure that there is no difference in quality of services received in any part of the world. In Technoform production plants, we understand that quality of product solution is paramount, as the solutions we are providing will be part of the facade that is designed to last many years. Hence, we do rigorous tests starting from the incoming raw material to the outgoing finished goods. We also do some tests in 14024 as well as EN 1279 on the production plants itself to ensure that we are providing solutions to our customers so that they can have a peace of mind and not worry if the assembled aluminium profile or the IGU will pass the actual standard verification. In addition, the competence center in Germany and laboratory there as well is well equipped and certified to do EN 14024 as well as EN 1279 tests. We also do have 2 training academies that allows us to bring awareness to the benefits of adopting international standards. As my presentation is coming to an end, I would like to highlight 4 key takeaways that I hope that you have gained today. With the demand for better performing facade as global temperatures are rising, we should not neglect the frame as well as the edge of the glass, as they are also able to transmit heat and they are the weakest link. With the introduction of thermally broken frames as well as insulating glass to solve thermal transmittance in the facade, standards like EN 14024 as well as EN 1279 are actually put in place to ensure the durability and lifetime performance of a facade. A durable facade not only look at the right selection of material, manufacturing processes are also vital in ensuring that the assembled aluminium profile will conform to EN 14024 standard, which in turn ensure durability and lifetime performance. Lastly, durability of IGU is not only the glazing. Technologies for edge bond are also critical in ensuring durability in IGU, like minimizing gas leakage and moisture penetration. The durability can be ensured by selecting a proven technology and material which conforms to EN 1279 standards. Like for example, a good sealant and spacer to ensure good adhesion for both the primary and secondary seal, which is crucial. So I have come to the end of the presentation. If there's any questions of project that you would like us to assist in optimizing your facade design using our technology, or would like to simply learn more about the company and what other solutions are able to provide, feel free to contact me with the details here on the screen, and we'll be able to set up a face-to-face meeting. If physical meeting is not possible, still feel free to reach out to me and we'll be able to communicate using other methods. Yes, and one more thing. We will be setting up a booth in Glasstech Asia in Singapore from 26th to 28th of October. So do drop by our booth at E07 Hall C if you are in the vicinity. And once again, thank you for your attention.
Thank you, Derek. Thank you for the very informative sharing of your Technoforms technology. Okay, without further ado, let me just kick off with the questions that we have from the audience. So one of the questions is that how is warm edge spacer different from aluminum spacer that we usually use? Can it be used in all types of windows?
Okay, so warm edge spacer is actually made up of co-extruded using polypropylene as well as stainless steel. So they have a lot of different kind of benefits to it. One of it is to actually improve thermal transmittance, because aluminum spacer actually has a thermal transmitter of 160 watts per meter Kelvin. So in this way, they are able the so-called double glazing unit, they are unable to prevent the heat from coming through the edge of the glass. So with a warm edge spacer, we will be able to prevent heat transmittance from the external to the internal, from the external to the internal. That is the primary role of a warm edge spacer, is to prevent heat transmittance either from the inside to the outside for hot regions like us, or maybe during the winter season is to prevent the heat from escaping from inside the room itself. But of course, there are also other benefits that Technoform warm edge spacer has, because Technoform warm edge spacer is actually made up of polypropylene, which is actually a resin. So we are able to do many different kind of colors. We can talk about black, white, gray, champagne. You know, unlike stainless steel, it's actually highly reflective. So many of the architects that we speak to, they are actually quite intrigued with the fact that our warm edge spacer is actually not reflective, and it's actually matte color. So they like it a lot. And also another thing is that we also, with warm edge spacer, because it's actually going through it's like glass, and then it goes through another so-called medium, followed by which it goes through another glass again. So in terms of acoustic, we are able to have some noise dampening as well. So yeah, that's the difference.
Thank you, Derek. So in that case, the warm edge spacer not only perform in terms of performance, it is able to meet different aesthetics needs as well.
Yes, that is correct.
Yeah, that is great. So, okay, we have another question for you, Derek. It goes this way. Structurally, can we calculate the aluminum profile using thermal break as one whole profile instead of having separate profile?
Okay, so to answer, just to ensure that I understand the question. So basically, the question is asking if they are able to calculate the aluminium profile using thermal break as one whole profile instead of a separate profile. Did I get the question correct?
I would think so. Maybe you can answer from that understanding.
Okay, so aluminium profiles structurally it is two different things, right? Because aluminium profile is actually is extruded using one whole entire profile. So the thing is, during the structure, I'm not an expert in structural calculation, because we specialize in thermally broken system, but in terms of the coefficient, the moment of inertia, it has to be calculated differently. So because as I mentioned before in the PowerPoint, one whole entire aluminium profile, when they experience loading, is actually rigid. Whereas once you have two different things, is actually considered a hybrid combination. So by mechanically fastening the process is actually to mechanically fasten the thermal break to the aluminium profile, and then this will give rise to a different kind of moment of inertia. But the moment of inertia has to be calculated separately from the traditional way of calculation. But in the EN 14024, they have actually listed out the steps for you to calculate in an event that the so-called the developers decides to use thermally broken assembled thermally broken profile. So with that, you will be able to aid the so-called the designers to calculate the aluminium profile structure. Yeah.
Thank you, Derek. Okay, I think our participants are now all warm up and putting in the questions in the chat box, which is really great. So I see that there is a customer, Harry, that says that he has been using your system, and but he commented that, you know, they are very satisfied with the products and the technical team has been very helpful with their designs. But there are certain cases that their profile is very bulky due to EN 14024 requirements. So what is the usual or the range of the U capacity of thermal material used in your thermally broken profile?
Okay, so it all boils down to the U value of the fenestration or the design that they are trying to achieve. By using, like in my PowerPoint, by using as small as 14.8 mm, you will be able to improve the U value by about 38%. So I mean, there is actually, by using a thermally broken profile, a thermal break in the system, there's actually very minimal kind of increase in terms of the framing. So it will be, I mean, there will, by increasing, because what is happening is that the aluminium design has to be designed by the designer, and it also has to be decided by the U value itself. So the thing is, if it's bulky, I mean, they can always consult us, and we will be able to help ensure that the so-called assembled profile will be within their requirement. Yeah.
Okay, thank you, Derek. Okay,
Yeah.
Maybe one last question for you before we start the discussion round with all our speakers today. So Derek, is the warm spacer called SP13 type? What is the good characteristic as compared to normal spacer?
Okay. So I mean, warm edge spacer is a generic term that is used commonly in the European country. So the reason why why is it called warm edge spacer is because they are able to trap heat from coming through the double glazing. That's why it's called warm edge. Whereas aluminium is what they call it a cold edge lah. So there is a good characteristics, I would say, is thermal performance. Okay, as mentioned before. The other benefit, the other advantage is, of course, there is high level of design flexibility. Okay, And it also enables the bending. It also enables us to enable the so-called the manufacturer, okay, of the IGUs to have the ease of bending, because our SP13 is able to bend to a very small radius, and at sometimes it also allow customers to do negative bending as well, is to bend the other way. Yeah, so SP13 is able to use in curved glass as well. So besides just SP13, we also have SP14 for customers that requires a little bit more rigidity towards the manufacturing of the DGU. Yeah, so of course we have also a wide other range of solutions as well, but feel free to come to my booth, then I will explain more in details.
That's a good one, Derek. I like that. Yeah, so please do visit Glasstech Asia next week. And if you have any questions for Derek, feel free to visit his booth. So at this point of time, I like to actually invite all our speakers to come together, and then maybe we can start a discussion round, because I see that there is actually a very good comment from Harry in the chat. Let me pull out what he has commented earlier on. Just one moment. Yeah, I think Harry actually has made a very good comment with regard, to our industry has been looking at maybe more of the operational efficiency or operational carbon, like energy efficiency savings through technology of using, I think he quoted like the LES technology, solar panel, but maybe our industry has not looked a lot in what we call the embodied carbon of the production process of all these materials. So I thought it will be interesting maybe just to have a round table discussion here to get our speakers' view on Harry's comment here. Do you feel that, in our industry, that means in our construction industry, have we been overemphasizing just on the operational carbon in terms of the technology that we have to save the amount of energy, but not do enough in looking at the production process of all these materials? Yeah, so maybe so maybe I'll get Philip to comment first, because yeah, Philip, would you like to share your thoughts on this?
Okay, I do agree with Harry in a sense that a lot of emphasis has been given to the functional benefit of what you call decarbonization. But then I think not enough of it has been given to the embodied energy. And he mentioned about the solar panels. Okay, solar panel is not exactly used to be a high embodied energy component, but since then it has been substantially reduced to the extent that the embodied energy of most solar panel now can be offset within a matter of a year or two, right? More like 3 years. Whereas I would say, for example, the glass industry is a huge embodied energy involved, but because we were going with ETTVs and all that, in that way, it somewhat cushion off the effect of the embodied energy used by glass. And aluminum is a very energy intensive industry. We have studied the carbon footprint of aluminum. Is probably come out top among the rest of the what you call the so that's one thing. The other thing is, I think it was mentioned of the LES, whether it is a low carbon embodied energy. I can tell you one thing: LES uses a very simple form of manufacturing process. In fact, it is probably also the oldest form of manufacturing process. It simply use printing, and the printing is done under ambient temperature. The only heat that we will probably use is the heat to laminate the glass together, And that again is also not a huge amount of embodied energy because the temperature used is only about 140 degrees C. So on an overall basis, I think LES I can consider to be a very low carbon production. Given the high energy saving, I would say the energy offset could be in terms of weeks and months, not years, right?
Thank you, Philip. I think that's a very good insights that, the amount of energy that is able to save from the operational will probably offset in terms of the production process in some of the energy that is being consumed. Yep. So maybe I'll move on as well to Lina as an architect. What are your views, on that aspect of the sustainability? Do you feel that our industry is doing enough to look also at the embodied carbon, or there are more that we can do? And do you feel that it is necessary?
I think, sorry, I really can't speak on this. Normally, we have a sustainability engineer who advises the details for all these issues. So they are more well-versed on these items. Yeah.
Okay, no worries. Yeah. I think the important part from an architectural point could be that, if we do use a material that is low embodied carbon and still able to help in operational, but still deliver the performance and able to fulfill the design freedom that architects have.
Yes, of course. Thank you. We will normally listen to the options offered and the advice given by them, and then we will consider that and see what best we can do to fit into the aesthetic.
Yes, correct. Okay, so I maybe move on to Derek because I think Philip has mentioned that aluminium is actually very high intensive production, but I do know as well in Technoform, if I remember correctly, you do have also what we call a low carbon aluminium. So do you want to make give us a few insights of what you think on this subject?
Okay, so in Technoform, we don't produce aluminium. We produce thermal brick, which is actually the PA66GF25. So we specialize in engineered plastic base because we have like over 5 decades of know-how. So I think at this point, I want to share that we should consider beyond embodied carbon as beyond embodied carbon of a product. We also need to evaluate the operational carbon for implementing technologies. So I'll give you an example. The embodied carbon for a single glazing is 2.5 times lower compared to a low-E double glazing. But does that mean we should actually stick with single glazing? Because in my presentation, single glazing transmit actually more heat into the indoor environment, which requires more cooling compared to the double glazing unit. So, in this case, the air conditioner will actually have to work harder. When they work harder, they use more energy. So when they use more energy, more electricity means more operational carbon is being used. So actually with thermal brick and warm spacer, the electricity saved as the room require less energy to cool. Then this kind of saving actually translate to what we call a carbon payback for adopting energy saving solutions. So for us, we have actually done a carbon payback study, and by using our technologies like thermal break as well as warm spacer, so the carbon payback is about 3 to 4 years. Depending on the system design and the use. Yeah.
Thank you, Derek. I fully agree. I think the first priority will still be the operational efficiency, because that helps to reduce on a longer run, right? Especially buildings, we are talking about 30, 50 years, how to reduce the energy consumption of it. That is definitely the priority. And if we have already reached the optimum in that aspect, then we can look at what others we can help to reduce the carbon to save our environment. Yeah. So I'm not sure whether Richard is there, but maybe I'll just move on to Vance so that he can give us his perspective from a consultant, from his consultant perspective. Yeah.
Yeah, okay. Sorry, Gwen, actually, what perspective do you want to hear from me?
Yeah, sorry.
I missed it.
Yeah, no worries. So I was saying that there was this comment from Harry saying that, we in our industry tends to look a lot on technology, new technology that can help us to save operational carbon, but we ignore the production process of it, because the production process of that technology could consume more energy. So yeah, so that's where I thought that it will be interesting to have everybody's view on this. Do we feel that how our industry can actually look beyond just the operational carbon, or the saving of energy from the operation phase to looking at the materials production process and carbon emission?
Actually not true, because in Europe we've been if we talk about just facade materials, aluminum, steel, glass, PPBs, sealants, we've actually been undertaking a study how much carbon it actually takes, say, to produce 1 kilogram of steel versus 1 kilogram of aluminum, or even to the extent, say, aluminum curtain wall system, say of a size 1 meter by 2 meters, to achieve, say, on a 30-story building, and then we replace the aluminum with steel. So how thick or how wide this steel is translates to the kilograms. Then we try to find out what's the production carbon actually. So, but this is still an ongoing study, because it's quite new in Singapore, and facade is actually a very specialized trade and involves a lot of materials. So we hope to close this study towards the end of the year, so we know all the numbers from extracting the material to production to operational carbon. Yeah.
Thanks, Van. So it's good to know that actually, as an industry, we are actually advancing as well to have studies and statistics and numbers to help us to know, between the different materials, how much is the embodied carbon. So it's good to know that Arab is one step in advance and looking at all this. Yeah, so that's great. And I think that will also help our industry to advance to use materials that are maybe low carbon, that helps to contribute to our climate.
Yeah.
So
that's
I see
what
that
we
Richard,
aim to do. Yeah.
So I see Richard is now on screen. So I do not want to miss him as well. So Richard, would you also want to share with us your perspective on this? Yeah.
No, I'm probably not an expert to provide any kind of perspective. So
yeah, but more than in terms of the sustainability part, your own views but you talk about it.
Well, personally, it's the green movement is a big plus, and everybody should head in that direction. So I think most of the topics here are generally in their regard. So for my product, not for my product, for AGC's product of ETFE, that certainly is in that direction. And again, you're just scratching the surface of the multitude of products, that AGC is churning out, for as far as green products are concerned. This is just part one of the many that they have. There's a fantastic R&D department that just keeps churning new sustainable products and also improving on existing ones.
Thank you, Richard. In fact, I did see that AGC just announced that they, in APAC, in Southeast Asia, they now have low carbon glass manufacturing. So I thought that, this is definitely also what we see. Most of the building materials are also moving towards how they can produce their materials more energy efficient and lower carbon, which is great. Okay, so I think we have come to the end of our webinar. I'd like to thank everyone for your participation and staying on with us for the last, almost 2 hours. And I also want to take this opportunity to thank all our distinguished speakers. And as well as PERAFI and Glasstech Asia for organizing this. And not forgetting a big thank you as well to AGC Group and Asahima's Flat Glass for their kind sponsorship that makes this webinar possible. So you see on the screen QR codes relating to where you can actually scan and get connected to the various organizations so that they can stay in touch with you. I also would like to shout out that this particular webinar has been recorded. So I do encourage you to access Glasstech Asia's website. There is actually a content hub where you can access and watch the recorded webinar on demand, and it is free. So last but not least, do remember Glasstech Asia and Fenestration Asia exhibition and conference is taking place next week from Wednesday to Friday. So please do come and visit, as what Derek has mentioned. So last but not least, you will be directed to complete a feedback form after you leave this webinar. Kindly complete them so that it can actually help the organizer to improve for the next webinar. So with that, I'd like to thank everyone. It has been a great pleasure to be your moderator and host. Till we next meet, take care and stay safe.
Thank you.
Thank you.
Thank you. Thank you, everyone.
Bye-bye.
Bye-bye.